Okay, here are the lesson notes for Module 1, Topic A, Lesson 4 of Geometry. We're going to do some classwork the first opening 5 minutes. You worked with your partner, looking at the problem set from last night, looking to see if all the constructions were done correctly. You follow the rubric in your Lesson 4 classwork section. We've got a needs improvements, a satisfactory, and an excellent. Basically, needs improvement. You didn't do much that you were supposed to. You've got few construction arcs. You've got few vertices or relevant intersections labeled, and the draw lines are not drawn with a straight edge and not drawn correctly. And fewer than 3 angle bisectors are constructed correctly. Satisfactory, some of the construction arcs are visible, most vertices and relevant intersections are labeled, most lines neatly drawn with a straight edge, and 3 of the 4 angle bisectors constructed correctly. And excellent, they were all constructed correctly, all the lines are neat, drawn with a straight edge, all vertices of the intersections are labeled, and the arcs are all visible and appropriate. Then we took a moment, everyone put a dot up here to show where the class ended up, to know if we needed some more work on this or if we're just kind of getting it. So the rest of the lesson is going to focus on perpendicular lines, constructing perpendicular lines, constructing perpendicular bisector of a line, and constructing parallel lines is a problem in the problem set, and we're going to do this by modeling. So we want to verify the construction by folding an angle along a bisector. We want the correct construction means that 1/2 of the original angle will coincide exactly with the other half, so that each point of one ray of an angle maps onto a corresponding point on the other ray of the angle. So what does that even mean? Well, coincide and map kind of mean the same thing. They mean when you fold the paper, they land on top of each other. So let me give you a brief demonstration of that. You're going to take this picture at the bottom of your workbook and you're going to copy it onto patty paper. So take a moment, pause the video, and get that copied onto patty paper. Okay, so your patty paper should look something like the one I've got right here. This is point A, point B, point F, C, E, and J, and D, and G. So what we're going to do is we're going to fold the patty paper along the ray AJ. When you do that, you should see that ray AF coincides or maps onto ray AG. And this center segment, this DC, is on top of BC. Point B and point D are on top of each other. Point C is the same because it's right on that ray. And then you've got FE maps on top of GE. And point G maps on top of F. Notice that BD is perpendicular to AJ, that's 90 degrees, and FG is perpendicular to AJ. The distance from E to G and the distance from E to F is the same distance, and D to C and B to C are the same distance. So we want to imagine a segment that joins any pair of points that maps onto each other. So we saw that B and D mapped onto each other, right? When you folded the paper, B landed on top of D. And E would map on top of G when you fold it. So EG, look at it. When the angle is folded along AJ, E coincides with G. So EF is equal to FG. We say equal because when you don't put the little segment over it, we're talking about the distance. So the distance from E to F is equal to the distance from F to G. And F is in fact a midpoint of EG.
Jacob, please call the office.
Likewise, if you look at a segment like EG, like BD, you'll see that B would map onto D when you folded it. And so the distance from B to C is the same as the distance from C to D. And C would be a midpoint. So C is a midpoint along AJ, and F is a midpoint along AJ to these segments built by points that map onto each other when you fold across AJ. So the angles formed are also mapping onto each other. So we know angle EFC is the same as angle GFC because when you fold them, they land exactly on top of each other. And since they are landing on top of each other, we know that EG has to be perpendicular to AJ, or this has to be 90 degrees here. Why? Well, EG is a straight line, and if EFC, angle EFC, and angle GFC are both equal to each other, then half of 180 is 90, and they both have to be 90, so it has to be 90 degrees. Which is basically what it just said here. So when you fold the angles on top of each other, we know that they're equal to each other, the measurements. We know that they equal 180 because EG is a straight line, and so they both have to be 90 degrees. So 2 points are symmetrical with respect to a line if and only if line L is perpendicular bisector of the segments that join the 2 points. So if I join these 2 points, we know the 2 points are not symmetrical because AB is not perpendicular to this line L. Now if I move point A over and adjust my segment here, they're still not symmetrical because this is still not 90 degrees. Let me put a box on here so you can see the 90 degree part. And I will adjust my box so it actually lines up here. Okay, so there is 90 degrees. Let me take my segment and make it match up. Put this over here. That's 90 degrees. And right there now the 2 points are symmetric with respect to line L. We've got to come straight across 90 degrees to be symmetric across line L. So a perpendicular bisector of a segment passes through the blank of the segment and forms blank with the segment. So perpendicular bisector of a segment passes through what? If we go back here, this is a perpendicular bisector, right? And it passes through what? What is it passing through here? Well, we decided F was a midpoint, so midpoint would make the most sense here. So fit a little midpoint onto there. And forms what with the segment? What are we forming? The perpendicular line here forms a 90 degree angle, right? So EFC is 90 degrees. So we would say that that is a right angle with the segment. Okay, so perpendicular bisectors of a segment pass through the midpoint and form right angles with the segment. Okay, so the next thing we want to do is we want to construct a perpendicular bisector. Knowing what we've known from our last lessons about bisectors and how we did constructions, we want to list the precise steps here. So take a moment, see if you can do this on your own, and then come back and watch it. Okay, assuming that you have taken a time to watch this or to try it on your own, this is segment AB. I'm going to take my compass and I'm going to draw a circle centered at A with radius AB. Okay, so my compass is centered at A, the point is on A, and it's got a radius here of AB. So I'm going to draw my circle. And that is my first step. Draw circle A, centered at A, radius AB. Then I'm going to do the same thing from B. I'm going to take and draw circle B, and circle B is going to have radius BA, so I didn't adjust the width of my compass at all. So draw circle B centered at B with radius BA, and BA and AB are the same thing. So let me draw that circle. Okay, the next step is going to be to label my intersections. So I need to label my intersections here. So I need a dot. Put that up here. Okay, So I've got a dot to label that one and a dot to label that one. And I am labeling my points of intersection as C and D. Okay, so labeling point of intersection C, labeling point of intersection D. Then I'm going to draw a segment that connects C to D. And that is the last step. This is now a perpendicular bisector. If I put a little square in the corner, you'll see that this does in fact line up. Okay, so that is a right angle right there. And this distance from A to the center and B to the center are the same. Also, the distance from C to the center and D to the center are the same. So we have congruent segments here. So let's go with A to the center and B to the center are the same. And C to the center and D to the center are the same. So now I have constructed a perpendicular bisector of segment AB. Okay, so going on to the next part of our lesson, we used a compass, string, or patty paper to examine AC and BC. Since I'm on my smart board here, I'm going to use a compass, but you could use any one of these three, a compass, a string, or patty paper. And we want to know what we notice about segment AC and segment BC. Well, let me pick up my compass here, and I'm going to center it at A, and I'm going to swing it around here, and I'm going to make it the same radius as C, so it's basically looking at a circle that's centered at A, radius AC. And you can see that we come right across, and I'm just a little bit too high. There we go. Now if I swing this over, and I put this on B, I'm crazy all over the place here. So I'm going to center it at B, and I swing it on up to C. You're going to see that that's the exact same distance. I didn't adjust the width of my compass at all. So the distance from A to C and the distance from B to C are the same. And so we call that congruent, or we can use the congruent symbol. Congruent symbol is that one. So that is congruent. So let's look at AD and BD. So let me move my compass out of the way. Let's look at segments A to D and B to D. And we'll grab the compass and put it over there and basically use the compass to measure distance from A to D. Okay, and then we'll move this over and measure the distance from B to D, and you can see that they are the same distance also. So that is also congruent. Okay, so A to D to B to D is congruent. So now we'll look at A to E and B to E. So A to E and B to E. And we're going to adjust the compass. So that it is the distance from A to E. We can probably move this up a little bit. There we go. Okay, so I'm the distance from A to E, and then I'm going to move it over to B, and just swing it around, and you'll see that that is the same distance right there. Okay, so A to E and B to E are the same distance also, so we call that congruent. So it would be likely to guess that every point on this bisector is going to be the same distance to the endpoints of the segment that it bisected. So any point on the perpendicular bisector, C, D, E, or any other one you draw, of a line segment is the same distance from the endpoints. A and B are the endpoints. But instead of writing the same distance, we write the word equidistant. So that word equidistant means the same distance, but equidistant is the geometry word for that. Okay, the next thing we need to do is we're going to make another construction. So we're going to construct a perpendicular line to L from A. And we want to write our precise directions, and I'm going to give you the first direction to start you off. So take a moment, draw line L, draw point A, and then come over here and look at the first direction, which is draw circle A, centered at A, with a radius so that your circle is going to cross this line twice. So pause the video and get that part done. Okay, so I'm going to take my compass, now that I've got my point A and my line L, and I'm going to adjust it to make sure it crosses this line L twice. And I'm going to draw my circle. Okay, the next step is, in every construction we've done, basically, is to label our intersection points. So I'm going to take this dot right here, this point, and label that one, and label this one. So step 2 is, in fact, label the two intersection points, and I'm going to label them B and C. Okay, likely thing that we should do next. Well, from previous constructions, we've then taken our compass onto our intersection point, and we have drawn more circles. I adjusted my compass there, so I'm going to change the color of my compass so you can see that it's a different width. So this is going to be from B to C. I'm going to draw that compass. So draw circle B centered at B. Well, I did C, sorry. Circle C centered at C, radius CB. And then I'm going to move my compass over, and I'm going to do the same thing. I'm going to do circle B centered at B, radius CB. So I'm not adjusting my compass here. And I did adjust my compass, and I'm just off just a little bit from where I was before. So the next thing to do is going to be label my intersection again. So I'm going to label the intersection, this one down here, as point D. Oops. I keep doing that. There we go. Labeling that intersection as point D. And then you can see pretty clearly that if I draw this segment right here, it should be a perpendicular line to line L, and that is in fact my last step here. So I'm going to draw AD, and AD is perpendicular to line L. So you want to make sure you pause the video, make sure you got the right steps with the very precise directions, using the correct words in the right order, and you've got your construction done. You can always back up the video and watch it again if you need to. Okay, we are close to done for the lesson here. So we've got a couple definitions. Right angle. Right angle is an angle that's 90 degrees. Notice the little red square in the corner. The red square means 90 degrees. So anytime in a picture that you see the little red square, we know we have 90 degrees or perpendicular lines. Perpendicular means two lines intersect at the 90 degrees. So you've got right angle, which means 90 degrees, and perpendicular, which basically means you've got a right angle. So this is a segment and this is a ray, and these two are considered to be perpendicular also, even though they don't touch. If I did move this down and continue it, you can see that that is in fact 90 degrees. So if the line that contains this segment and the line that contains this ray were to meet at 90 degrees, then they are considered to be perpendicular. So even whenever I've got it drawn like this with this segment up here and this ray over here, you can't see them where they cross, but they would in fact be 90 degrees if they did cross and you extended the lines that contain those segments. And equidistant is our last vocabulary word, I think. Equidistant is our last vocabulary word in here. So equidistant means equal, equal, distant. A is equidistant from B and C, okay, if they are the same distance. So if I take and look at this, this is 3 centimeters from A to B, this is 3 centimeters from A to C. So A to B and A to C are equidistant. And they are also equidistant to a line if you are the same distance from the line. Notice that you go 90 degrees or perpendicular to the line when you measure to a line. You would not measure off it at some strange angle. Okay, you're not measuring over an angle. You measure at 90 degrees to the line that you're talking about. So this is 4 centimeters away from the line, and this one's 4 centimeters away from the line. So they are not mapped onto each other. They are not symmetrical, but they are equidistant to the line. And then tonight's homework is got problem set 3 and a crossword puzzle with all the vocabulary words that we talked about today.